Now that we have understood the concept of the API connections, let's move on to premium or proprietary connections. There are no standard design for premium connections. Manufacturers have their own preferences, so they design different type of threads. Even the same family of threads could include different brands and models. Premium connections dramatically enlarge the portfolio of connections available on the market. The main characteristics of proprietary connections are the thread geometry, the thread profile, the seal design, and the sliding distance. The thread geometry is related to the taper, the stabbing flank, the load flank, the threads per inch, standoff, and so on. The thread profiles vary according to the application and the well design. And based on this, there are different shapes of threads, each of them with a particular benefit. Some profiles are flank to flank, crest to root, hook thread, dovetail, etc. Talking about seal designs, referring of course to metal seals, they come in a wide range of shapes which provide different pin box contact pressures such as cone-cone, sphere cone, multi-taper cone, and so on. And finally, the sliding distance is the distance from the very first point of the pin box seal contact until it reaches the final makeup position. In general terms, the shorter the sliding distance is, the lower risk of galling of the seal. Well, let's talk now about the different type of premium connections. The most typical connections used in the oil and gas wells are the threaded and coupled, where two pipes are made up together through a third element known as the coupling. In addition, threaded and coupled connections are available in different types, such as the standard coupling, which has the OD specified by the manufacturer, special clearance, which has a reduced OD with higher clearance in the well, but resulting in a reduced tension efficiency. Match strength, which has a reduced OD, keeping the same tension resistance as the pipe body. And finally, the special bevel coupling, where their faces have been chamfered to be used in dual completions or horizontal wells to minimize drag forces. Apart from the threaded and coupled connection, we have the integral connections that, as explained before, join two pipes without a third element or coupling. Depending on the application, integral connection can be classified as integral flush connections, where the OD of the connection is the same as the OD of the pipe. So the entire string has a continuous and equal outside diameter. These connections are used in wells in which clearance between pipe and pipe or pipe and hole is critical. Then we have integral semi-flush or near-flush connections, which have an OD slightly larger than the OD of the pipe body, generally from 2 to 5%. Near-flush connections require an expansion at the box and a swedging process at the pin end. During the expansion of the box, the external diameter is enlarged through a cone at room temperature, resulting in a diameter a little bit larger than the pipe body. The swedging at the pin end means that is circumferentially deformed towards the internal diameter. This allows the cutting of a seal with a homogeneous thickness. Integral semi-flush connections are also used in wells with restrictions in the clearance between strings. Their tension resistance is higher than the resistance presented by integral flush connections, but lower than the one found in threaded and coupled connections. And finally, we have the integral upset connections. These connections are threaded on pipes with ends that have been subjected to a process called upset. This process involves heating the ends of the pipes and pressing them in order to increase their wall thickness. The thickness increase results in a stronger thread geometry. Upset integral connections are especially suitable for downhole operations such as rotating and drilling a plug of cement, or running and pulling out strings several times in a stimulation or fracturing operation. This application is known as work string tubing.